welcome all. My name is Jeffrey Glucksmann. I'm going to talk here with my colleagues Wei and Tyler about the customizations of CloudStack we did within Leaseweb. So we're the CloudStack team. We're currently a team of 10 developers working from 8 countries, mainly working within our Amsterdam office in the Netherlands. And we have Tyler working from our Phoenix office. And we have a colleague working from Bulgaria at the moment. We're building the CloudStack platform for Leaseweb. Doing this for over 7 years now. Running multiple CloudStack platforms over multiple continents. Currently over 1,000 servers within our platform. Located in 6 data centers. And currently we're at 49 commits to the Apache CloudStack platform project. So a little bit about us. I'm Jeff Glucksmann. I'm senior engineer for the CloudStack team. We have our DevOps infra specialist Tyler and our principal CloudStack engineer Wei. The agenda for today is we'll talk about why we needed customizations in CloudStack, what we did customize, the challenges we faced during these implementations, and our future improvements, which we're planning on doing within CloudStack. So first point is we did the private interconnect. We're connecting our private clouds with our dedicated servers. We did a multi-NIC support for CloudStack, improved volume management, containerizations within CloudStack, NoVNC console, and customized load balancers. And some features that made our life easier for DRS, for managing and balancing the VMs, and centralized logging, so we could easily see what's going on within the virtual routers. So the first point is private interconnect. So we have some customers at Leaseweb who run both bare metal and cloud, and these customers wanted to interconnect their dedicated servers with their cloud. So we needed to figure out a way on how to connect these two platforms. So the current setup is we have a customer with its own rack with dedicated servers, and we have our cloud platform. We solve this by connecting the dedicated servers and the cloud platform over a private interconnect directly between a switch within the customer's rack and connecting it to a network in CloudStack. Once everything's set up, we could easily test that, just ping both machines, see if everything's reachable. Right?
So the question I have is that, so your company is more of like a system integrator for CloudStack, that you provide CloudStack to your customers, or?
We're a hosting company, so we're providing hosting services to our customers. So both from dedicated servers to co-location, shared hosting, cloud products. Yeah.
If I'm a company, I want some virtual machines and infrastructure, I come to you.
Yeah. Yeah, so you can get VPSs for just a simple VPS virtual server, or we can deliver a CloudStack infrastructure for you, so you just get the login to CloudStack and can manage your virtual machines. Yeah. So we can connect these two platforms either with a single connection, redundant connection. That's all up to the customer, depending if he needs redundancy or not. So once everything's connected, we have our customer rack connected to switching of our CloudStack platform. And then within CloudStack, we will get an extra network for this. So this is connected. By default, we're offering redundancy on our CloudStack side with a single switch on the customer side. That's either connected over a single link or redundant link, depending on the customer's needs. And it's of course optionally to get a redundant switching as well on the customer side if the customer has the need for this. And this is connected over an LICP, so that in case one of the network devices fail, that the other one will take over. The methods of interconnection in CloudStack are 2 ways we offer this to our customers, either with a shared network or with a VPC network. So the advantage of the shared network is that the customer can either create a gateway on his dedicated side, on dedicated rack side. He can create a virtual router there, or on his dedicated machine to route internet towards the internet from the VMs over the internal link to the internet. Could also do the other side, create a gateway on his virtual machine and use that as a gateway for its dedicated service. We have isolation through VLANs, and when the shared network is applied on the domain level, then the customer can have multiple accounts using that internal network. However, it's the customer's responsibility to set up the DHCP networking. Since the DHCP within CloudStack automatically has a list of all the VMs and will assign an IP based on the available pool within CloudStack. However, the dedicated servers are not within this pool, so the dedicated servers will never get an IP from the DHCP server of CloudStack. And running two DHCP servers at the same time, so one for the customer's dedicated service and the cloud, well, that's not really recommended. So we just offer a shared network without any services, and then it's up to the customer to either configure static addresses or use its own DHCP server. Of course, the speeds between the two platforms is depending on the customer's connection. Customer can connect on 100 Mbit, gigabit, 10 gigabit. Completely depends on the customer's need. For the VPC, servers in the private rack can use the VPC virtual router to connect to the internet. And another pro is that the customer can, in case he has multiple private clouds with Leaseweb, for example, one in Amsterdam and one in Germany, he can create a site-to-site VPN connection between the two platforms. And over this VPN, he can also access his private servers that he has within the Amsterdam location. However, in case of VPC, then the VPC router will become a bottleneck. So depending on your needs, make sure you give the router enough resources and proper network connectivity. Multiple physical networks. So within CloudStack, we experienced that it's only possible, you have a physical network, and when adding an additional physical network, you have to provide this with a tag. However, when using this tag, then the first network is not selectable anymore. So the programmer made a change that by default, the primary physical network is always available, even if it does not have a tag. And then we can add multiple networks with a tag. We created this because we physically split the public traffic and the CloudStack internal traffic over a different network layer than the traffic towards the customers. To get network isolation. To make sure that everything works for us as needed. Okay, now I'm going to hand it over to my colleague Wei, who's going to talk to you about multiple NIC support that he added in CloudStack.
Good morning. I will talk about some of our improvements on the networks, on volumes, on VM console, and the containers. And first, multiple NIC support in KVM. Why we need this one? Because 2 years ago, we migrate around 3,000 containers from OpenVisit containers to CloudStack. We had a problem that many containers have IP and have multiple IPs and multiple NICs. And when we migrate the containers to our public cloud, where we use advanced zone with security group, and it's not possible to create new VPS in the advanced zone with security group. We got this error. Cannot create a VM with multiple networks, of one which security group is immutable. And so we try to solve the problem in another way. We try to first create a virtual machine with only one NIC, and then add some other NICs to the VPS, and the operation succeeds. However, only the first NIC works, so only the IP on the first NIC are reachable. So we're thinking if we can support the multiple NICs and IPs. Our goal, first, the operation should succeed. We should be able to create VPS with multiple NICs on UI, on API, and in addition to it, all the IPs and NICs should be working fine. That's our goal. And besides this, because the customers have full control on his VPS, so he can change the IPs, change MAC address, add additional IPs. So all this we cannot control these actions. So, but all these IPs and NICs the customer added should not be working. So we need to block the IP address and the MAC address from CloudStack side. To solve this problem, we removed the restriction in CloudStack, so the operations are supported on both UI and API. And also, we applied the network rules through security group, and the network rules will be applied for all the NICs and the IPs. And when we remove the NIC and IP from the virtual machine, the related network rules should also be removed from CloudStack. We have made some changes in KVM. For KVM, in the KVM hypervisor, all the security group rules are applied by a Python script named security group .py. So we made some changes on it, and then for now, the network rules of all the NICs and IPs will be programmed, including the IP table rules for NIC bridge, for the IPs, for the NICs, and the most important thing, we have reflect the EP table rules, which created by the Python script. For now, in the mainstream, the only EP table rules of one NIC is supported. So after we reflect the EP table rules, now we are able to support multiple NICs and IPs. Now we are in the future, we will port all our changes to Cloud mainstream. As I remember, this feature is requested by some CloudStack users in the community. We have made some changes for KVM and IPv4. So it would be nice if someone in the community can join us to support more hypervisors and also IPv6. The second part, improvement on volume management. For most of us might know that when we for the virtual machines in CloudStack, we are able to destroy a virtual machine, and if we want to recover it, it's also an option on CloudStack UI. But for volume, it's not possible. If we delete volume on CloudStack UI, the image will be removed from the primary storage. So it's not possible to recover the image file. In CloudStack, the volume there is a state for the volume destroyed. However, the volume in destroyed state cannot be covered. So what we change? We have made some code, add some code in CloudStack to recover the volume in destroyed state, and also we added two API. So similar as the virtual machines, we can destroy a volume, and if the volume is not recovered in some period, then it will be removed from CloudStack. And if we recover the volume on API and or on UI, it's also possible. And the volume will be changed back to ready state, and then we can use it. So one use case for this change, for example, if the operating system of virtual machine is broken, then we try to fix it. Normally, we can restore the virtual machine. Then a new operating system will be installed in the virtual machine. In CloudStack mainstream, when we restore the virtual machine, the image will be gone, so we cannot get any data back. After our change, when we restore the virtual machine, it will allocate a new root disk, and the old root disk will be in destroyed state, and we are able to recover the state, the root disk in destroyed state, and then attach to the new virtual machine. So we are able to get the data on the new root disk. Third part, the containers and CloudStack. First, I'd like to thank ShiftBlue for their work on CloudStack container service, and based on the release, we have made some changes. For example, our CloudStack container service support multiple copyless versions from the old 1.7 to the latest 1.15. And some parameters of the containers cluster can be customized. For example, the VM template, root disk, and also we provide some more actions on container cluster. For example, scale in, scale out, and so that the virtual machines in a container cluster can be created or destroyed on demand. And we also have integrated the cloud load balancer to the container cluster. So if we create a kubeless service with type is load balancer, then the corresponding load balancer rules will be added to CloudStack automatically. So we do not need to manually add or remove the load balancer rules. And when we scale in, when we add a new VM to the container cluster, the load balancer will also be added to the CloudStack load balancer automatically. We also support high availability container cluster. I will give more details. High availability normally means more uptime and less downtime. So normally there is no single point of failures, and all the components are redundant. In the default setup of the container cluster, it contains one kubeless master and several kubeless loads. And on the master, there is the API server running and the etcd process, which saved the state of the kubeless cluster and also the services. So to achieve high availability, we need to create redundant components. For example, the API server and etcd. This is our setup of our high availability container cluster. It contains 3 masters, and all the etcd on all 3 kubeless master will be a etcd cluster. So once one kubeless master is done, the kubeless cluster is still running, and for the API server, it's implemented in the nodes. So we have NG running on all the kubeless loads. It will be listened on 8080 on local port, and point to the string API server on all the masters. NoVNC VM console. We need this one because some drawback of current VM console, and we want to improve it. to achieve, for example, concurrent access for the virtual machines and smooth user interaction, and to discuss continuous polling from our browser. I will give more details in my last talk, starting at 11:30 in a large room. Now, my colleague Tanner will talk about the rest.
My name is Tyler Wilson. I work for Leaseweb as well. I've been working there for about 4 years now. And I'm going to talk about, first I'm going to talk about load balance, the changes we made to the load balancer configuration for CloudStack. So basically we discovered early on into the CloudStack hosting game that we needed to alter our pretty much our setup, our providing of load balancing services through our private for private cloud customers. We had customers that were requiring different features, like say HTTP versions, or if they say one customer has a few amount of hits to their load balancer, and some customers have wanted quite a bit more capacity for their load balancers, and we needed something to configure CloudStack to support all these different customers. So we changed the load balancing system to support these different configurations of HA proxy, basically. So some of the ways we did this is creating a configuration file variable system, and these rules are applied to the HA proxy system on the VR through these configuration variables on the resource tags for the network and the load balancer. So we have the obvious ones like max connections. We have timeout variables. Different if you want to set the password for the stats page on HA proxy, you can do that there too. And if you want to just keep it online instead of restarting it, you can reload the configuration. Just some basic stuff like that, and it helped out our customers quite a bit because they were able to adjust their load balancing HA proxy without going to the VR and having to edit the HA proxy configuration. They could just type in some key value pairs into the network and pretty much be good to go. And more of the configuration files can be found in our knowledge base. It's public. Another really common request we got is customers that wanted to see the IP of the customers that hit their load balancer. And by default, you're just going to see the HA proxy VR IP. Whenever a customer from anywhere from Bulgaria to Russia to US, they're just the same IP. So we implemented support for transparent networks, and that allows our clients to see the actual IP coming into their web server from the load balancer. That allows them to track, stats for Google Analytics or any kind of analytics services, which ended up helping our customers quite a bit. And the way we did this is changing IP tables rules, IP route rules, and also, obviously, the HA proxy configuration. We also implemented support for SSL offloading, and we can actually decrypt and encrypt the HTTPS traffic through uploading the SSL key. And again, that's also changing a configuration variable in the network key value pair. Yeah.
All these changes, did you guys give it to CloudStack or
I'll go over that in the end, but not yet for a lot of these. Hopefully soon. I can't say a date, but hopefully. It's a lot of exciting features we really want to do for pushing. Yeah, it is. It's in the plan. Yeah. And one more thing. Actually, recently, we actually also enabled HTTP2 for our load balancing, and that's also set through a configuration variable, and that'll just change everything on the VR for you. You just need to reload the network, and good to go. And a lot of you may be familiar with trying to debug or trying to troubleshoot problems with virtual routers. It's pretty annoying actually to having to SSH into each VR and trying to figure out, okay, why did this network go down at 6 a.m. last night or 6 a.m. this morning? And so we finally got fed up with it, and we centralized our logging for our system VMs. And the way we have it right now is all of our logs are going to just one management server. And it's actually storing our logs for us too. So in case a VR does go down and actually gets destroyed through either customer interaction or just some sort of destruction action, we actually can see those logs on our management server. So it helps us out. Really helps us out for troubleshooting. And obviously, you can send these logs to Elasticsearch or Kibana, whatever log viewer you want to see. And the way we do this, just a quick flow, is we have our syslog. We have an our syslog on the system VM already, but it captures the cloud log from CloudStack itself, and also the system log. So if you have any sorts of network issues from Linux itself, it's going to capture that as well. Then the system VM forwards that our syslog information to the 169.244.1 usually. I think it's always 1. But it forwards that log to 1, and that's a special interface created on the hypervisor itself. There's a hypervisor VR connection there. Hypervisor is just configured to receive that rsyslog information and then forward it to the management server or whatever server you have. But it doesn't store anything locally. It just forwards that along to the management server here. And the management server collects and stores those system VM logs. So we have one central location for it. So this is the configuration file for the system VMs. It's pretty much a basic rsyslog forwarder, and that's for this is one is particular for the cloud log there for the CloudStack log, and also we have a forwarder setting up again for that 169.254 address, specially dynamically created on the hypervisor for a KVM. And on the management server, again, we collect these logs and store them in folders depending on what the host name is for the VR, so we can easily look at them later. And we also have a combined log just in case we need to see if there's any patterns within a lot of VRs happening like that. We can easily go through the combined log of every single VR on the platform and see if we see any issues. Okay, another thing that I personally have implemented and worked on is our dynamic resource scheduling. So if you ever had issues if you need to load balance your cluster, or pretty much allocate load throughout your cluster, not really load balancing, but sort of same thing, not really HA proxy, but basically when you have customers that are interacting through hypervisors, they all have different loads, and depending on these loads, your hypervisor load averages may be 90% to 2%. And what we developed is a way to analytically look at those loads and redistribute those VMs accordingly to better balance that process. And again, because different customers have different needs, and CloudStack usually allocates those VMs depending on what kind of resources they could use rather than they're actually using. CloudStack really doesn't really distribute those as needed, so we kind of have to go in the middle and fix those whenever needed. And it also allows us to give a standard of resources to our customers. So when a customer comes to us, they expect a certain level of hypervisor availability, and this helps us achieve that. So to make sure all of our load is within the margins. And again, the balanced cluster is obviously easier to manage because you don't have stuff kernel panicking through CPU limitations or IO load there. So it works through a Python script on the management server that runs set intervals. It actually tracks the load averages of all the VMs and all the hypervisors, and has different algorithms depending on which one you select to migrate to the highest, pretty much the highest loaded VM or lowest, whatever algorithm you check, to lowest scoring hypervisor in the cluster, and the scoring is depending on how you configure the variables within the DRS. So you can set memory if you value memory over CPU, you can set memory to be a higher weight than the CPU, or if you vice versa, depending on how your cluster is set up. And we actually, depending on it was initially created as just a hackathon project, but we have added affinity group support. We have a migration blacklist, so a VM has the option to not be migrated for X amount of time if it's been migrated again. Yeah. Yes. Currently, we ask CloudStack what load the hypervisor has for CPU and memory, and also as well for your VM. Yeah. A KVM. Yep. Yeah.
So when this Python script runs, it's always you set a set of rules and it applies it. It's not like VMware DRS is this option to suggest migration. Your module always execute the migration, right?
Yes, there is. Okay, so there is thresholds. So you can set where it will not balance a cluster if you set. So there's a standard deviation threshold. It will not balance it if it's below that or a standard. So it's within that. So it's within those margins, and that's also changeable. But yeah, it will migrate whenever it can, and how it chooses which hypervisor and which VM is dependent which is defined by which algorithm you choose, and also how you weight the different memory and CPU. Does that answer your question?
Yes.
Okay.
That code is public.
Not yet. I need to refactor. No, hopefully we will get it public. Again, things like affinity groups, which is a pain to get working. Migration blacklist, again, so you can actually define, so you don't want to migrate the same VM more than X amount of hours or days or whatever. You can define that there. It also supports our tagging. So we have our templates tagged to certain hypervisors. So Windows, VMs only go to Windows hypervisors, Linux hypervisors, and this actually understands that and matches those together, and it actually also rebalances. So if it finds ones that aren't in the same right place, that'll move them to the right place. And that's how DRS works. So some other enhancements we did over the years. So again, we touched on this, but volume management, we can actually recover things in destroyed state, which is really great for obviously when we have users that delete things that don't want them deleted. We do have autoscaling for KVM, which is pretty amazing. And we have the resource management for system VMs and customer domains. And we have the network domain, the VPC settings, and the virtual router offerings. Those. Some more enhancements that our colleague Rakesh made. Unfortunately, he couldn't be there today. That's why we're doing this presentation. But you wish we could be here. And he developed a CloudStack automation kit, also a new dashboard for the hypervisor upgrades. So he developed an automated way to upgrade hypervisors, mostly through Linux updates, and he made a dashboard for that. Also, a template manager for managing templates within CloudStack. So, a few things that are up on the horizon for us next is no duplication for secondary storage. So, by default, when you have multiple secondary storage VMs, that data is replicated throughout each one. And we want to give it an option to actually have multiple secondary storage highlights, so we can act as more of a load balancing situation rather than a redundancy situation. We also want to improve our database exception handling, because troubleshooting database exception is just a major pain if you've ever had to deal with that. Handling ISO deletions. So when you have VMs with ISOs mounted on them and you try to delete the ISO, it causes havoc within CloudStack, and we're trying to improve that functionality so it actually handles it gracefully. obviously we're trying to migrate to 4.13 and hopefully create more PRs about all of these topics within the community. Is there any questions? Other than I've already answered.
Go to two slides before this one.
Yeah.
So it says dashboard for hypervisor upgrades.
Yes.
What exactly that means? So when you want to upgrade your KVM, so it will do it automatically?
Well, it's primarily to automate, say, if you have kernel upgrades, or pretty much your monthly or weekly or yearly, whatever, how often you want to upgrade, all of your Linux updates to the hypervisor. So you could upgrade KVM at the same time, depending on what your repo is, really. But yeah, it basically automates the migration of VMs from that hypervisor itself. Finds a new hypervisor for all those VMs according to the rules you set it, so it only migrate things to the upgraded hypervisors already, so it doesn't have to migrate it again, and stuff like that. So
automating it, right? It's just like
yeah,
everything automatic.
yeah. And again, that's the dashboard for it there. I'm not sure if the backend code is there too, but yeah, that's what the project is about. Yeah.
Virtualization versus pass-through, because I saw Nick, you guys were using, so was it virtualized or is it pass-through? Same to the question for the graphics also, correct? Like when you deploy your VMs, so most of the IOs and the drivers, are you guys virtualizing or is it a pass-through?
Maybe organizing. Sorry, can you repeat the question again?
So you have Nick, correct? So I saw that Nick is basically used in multiple VMs, or is it associated with only one VM? So that means pass-through or virtualized?
Yeah, virtualized. Yeah. Yeah. All of our network are virtualized. Yeah, we primarily use Linux Bridge for our network. Any other questions? About anything you've seen? At our next talks, do you have a question?
Actually, I do.
Yeah.
This is kind of a bizarre question. So, why CloudStack, not anything else? Because I never heard of CloudStack until I recently started to search. But it looks like you guys have been into this business for a long time and know when it comes to customization. Why CloudStack, not OpenStack?
Well, I mean, I know they chose CloudStack. I was before my time at Leaseweb, unfortunately, but I was previous to OpenStack guy as well. But I moved on to CloudStack with joining Leaseweb. And I do know they actually looked at OpenStack and when they were choosing their provider, and they decided on CloudStack. I think they liked the community better. They liked how it was set up, a lot easier to work with. I wasn't around, but I believe that was they looked at both and they found CloudStack was better for everything, all of their needs. And it's been worked out. We've been working out for us ever since. Any more questions? Nay? Okay. So our next talk is Wei is giving it, and the next scheduling appointment is actually next door, and he's going to be talking about the NoVNC implementation, which is amazing. HTML5 is amazing. You should see it. And the next one from me and Jeffrey is going to be how we migrated. How we integrated a different company within that we bought and integrated their OpenZ system into CloudStack, and that's going to be tomorrow, 11:15. And if you have any more questions, we're going to be available for you. Just look for me, Jeffrey, or Wei. And that's
You're in Phoenix also? You guys are in Phoenix?
I'm in Phoenix, and Jeffrey Way are in Netherlands, Amsterdam.